Did you hear about the mysterious dimming of Betelgeuse in 2019? A recent study has shed light on the cause of this fascinating event. Researchers discovered that a cloud of dust formed from silicon monoxide molecules obstructed half of the star's surface, causing it to dim suddenly. In this episode, we'll explore a new study that used high-resolution images from the European Southern Observatory, or ESO, to reveal the cause of Betelgeuse's dimming. We will also discuss the significance and implications of this research for understanding Betelgeuse and other red supergiants. Additionally, we will address common misconceptions and myths about Betelgeuse's dimming event. Join us as we uncover the secrets and wonders of this incredible star. What is the cause of the dimming of Betelgeuse? A dusty cloud. In late 2019, just before the COVID-19 pandemic would grip the world, the scientific community was captivated by the sudden and unexplained dimming of Betelgeuse, the red supergiant star in the constellation Orion. The star had lost more than half of its brightness, leading some astronomers to speculate that it was about to go supernova, an event that was not expected to happen for another 100,000 years. However, within weeks the dimming stopped, and the star returned to its average brightness. Despite this, the episode known as the Great Dimming has left researchers with many questions to ponder. The explanations for the Betelgeuse Great Dimming emerged gradually from various observatories that had closely observed the star. Firstly, a team of researchers who had used the Hubble Space Telescope to observe Betelgeuse before, during, and after the event reported that a massive ejection of hot material from the star created a dust cloud that led to the apparent fading. Secondly, a different team using data from the Weihai Observatory in China found that Betelgeuse's temperature had dropped significantly during the Great Dimming, and the researchers attributed the drop not to a dust cloud, but rather to a large, relatively cool dark spot that had briefly formed on the star's surface. Finally, another team used observations with the Very Large Telescope in Chile to conclude that both scenarios were correct. According to this hybrid model, the emergence of a dark spot in the star's southern hemisphere lowered the surrounding temperatures and spat out a bubble of hot gas. An enormous dust cloud then formed from this escaping material as it cooled, which eventually led to the Great Dimming. For centuries, Betelgeuse has been observed by astronomers who have noted that it experiences cycles of brightness variations lasting 400 days. However, since the Great Dimming event, which occurred recently, there has been a significant impact on the star's regular pulsations. The pattern of brightness variations that were once observed has disappeared entirely, leading to speculation that the star's interior may have undergone a reshuffling of material. The implications of this event and its effects on the star's behavior are still being studied and analyzed by astronomers worldwide. Betelgeuse continues doing some very unusual things right now, Andrea Dupree from the Center for Astrophysics, Harvard and Smithsonian says. Tracing a traumatic outburst. In early 2020, the team led by Dupree started using the Hubble telescope to conduct a 3-year study of Betelgeuse, a massive and variable star. One of the team's main objectives was to monitor changes in the star's outer atmosphere. Betelgeuse's behavior is characterized by a 420-day cycle of expansion and contraction, leading to brightening and dimming. Thanks to Hubble's ultraviolet light sensitivity, scientists could explore the layers above the star's surface, which typically have temperatures exceeding 20,000 degrees Fahrenheit, making them impossible to detect with visible wavelengths. These layers are heated by the star's turbulent convection cells that bubble up to the surface, leading to a complex and fascinating interplay between the star's interior and outer atmosphere. Astronomers used Hubble's spectra to study Betelgeuse's outer atmosphere in early and late 2019 and 2020. They measured magnesium-2 lines and found that hot, dense material was moving at about 200,000 miles per hour from the star's surface to its outer atmosphere. This material continued to travel beyond Betelgeuse's visible surface and cooled down to form dust. Hubble ultraviolet light observations in February 2020 showed that the behavior of the star's outer atmosphere returned to normal, even though visible light images showed that it was still dimming. Betelgeuse's outburst was likely aided by the star's pulsation cycle, as observed by visible light observations using the Stellar Activity Stella telescope. The star expanded during the pulsation cycle, which may have helped propel the plasma through the atmosphere. Dupree estimates that about 2 times the average amount of material from the southern hemisphere was lost over the 3 months of the outburst. Betelgeuse, a massive star located relatively close to Earth, offers a unique opportunity to observe surface features not typically visible in other stars. Thanks to the Hubble telescope, astronomers have captured images of Betelgeuse's surface, revealing a fascinating mottled pattern with massive convection cells that regularly shrink and swell. These changes lead to areas of the star brightening or darkening, providing insight into the complex processes within the star. The ability to observe such surface details is rare, with Betelgeuse being one of the few stars, alongside our own Sun, that allows for this level of observation. Beetlejuice Supernova 2023. Could the star blow up? Astrophysicists have been in awe of the red star Betelgeuse for years, and for good reason. This blazing star is one of the brightest in our sky, and it has been keeping scientists on their toes since 2019. They were busy trying to unravel the mystery of why it had lost its brightness when, all of a sudden, it returned to normal in April 2023. But then, something incredible happened. In May and June of the same year, Betelgeuse suddenly became almost 50% brighter. This makes it a variable star, which is genuinely fascinating. What's more, this recent behavior has led scientists to believe that Betelgeuse might have entered the final stage of its life and could go supernova soon. Keep your eyes on the sky, stargazers, because this could be a once-in-a-lifetime event. What is a supernova? Why does a star's brightness change, and why might it explode? A supernova is a spectacular astronomical event that occurs when a star undergoes a catastrophic explosion, causing an abrupt increase in brightness levels. This explosion is triggered by a significant change in the star's core, which can be caused by various factors, such as a star stealing too much matter from its companion star or running out of nuclear fuel. When this happens, some of the star's mass flows into its core, causing it to collapse under its gravity and leading to the release of an enormous amount of energy. The resulting explosion is so powerful that it can outshine an entire galaxy for a brief period of time, making it one of the most fascinating and awe-inspiring events in the universe. Why do scientists think Betelgeuse may explode? Throughout its lifetime, a star undergoes a remarkable process of converting hydrogen into helium through nuclear fusion. This process is essential to maintain a delicate balance between the immense gravitational forces pulling the star inward and the outward pressure generated by the nuclear reactions. However, as the star gradually exhausts its hydrogen fuel, it starts to burn helium, which causes it to expand and form a red giant. Finally, when all of the fuel is used up, the star collapses, creating a dense and highly compact neutron star. According to a recent study by Japan's Tohoku University, the star might be in its final stage of life, the carbon-burning stage. The study's leader, Hideyuki Sayo, speculates that the core will collapse a few tens of years after the carbon exhaustion. But here's the twist. Researchers from Hungary's Konkoly Observatory have a different take. They believe that the star is actually in the earlier helium-burning stage of its life cycle. Who do you think is right? Betelgeuse will eventually become the next supernova of the Milky Way galaxy. However, this event will only occur briefly, and it may take up to 100,000 years for Betelgeuse's light to finally go out. Betelgeuse's fascinating behavior need not culminate in an explosion to pique our interest. Its peculiar oscillation between dimness and brightness still indicates some unique physics happening out there. The fact that stars pulsate on timescales perceivable by humans is absolutely remarkable. Betelgeuse, the red supergiant star in the constellation Orion, has continued to fascinate and intrigue astronomers for centuries. From its cycles of brightness variations to its mysterious dimming event in 2019, Betelgeuse has left researchers with many questions to ponder. While the cause of its dimming has been discovered, the potential for Betelgeuse to go supernova remains a mystery. As one of the largest and most massive stars in our galaxy, Betelgeuse is nearing the end of its life and could go supernova at any moment. The implications and effects of such an event are still studied and analyzed by astronomers worldwide. The mysteries of Betelgeuse continue to captivate us, and scientists are eagerly watching and waiting for what this incredible star will reveal to us next. We hope you enjoyed this video. As always, please be sure to share your thoughts down below, and don't forget to subscribe to our channel for weekly space updates. See you next time.